Okay, I hope you can see now. Organizing data. Hello, can you
Yeah,
see?
it's visible now.
Yes,
Okay.
sir.
So basically, what we talked other day, that we want whatever data we collect from any sample, we get only the raw data, and then we put it in the table in the form of frequency distribution, just to see what are if we just choose a specific class, how many number of particular values that we are appearing, and with the help of the frequency distribution, we organize all data in a tabular form, and we classify them. Okay, and this is the next slide. uh, Data presentation, ways to effectively present survey data. Okay,
Sir,
why
it's
do
slide
Sir,
three
you
only, sir.
slide.
a slide has not moved?
No, sir.
No, sir.
Every time this is happening, this I don't know why. I'm then screen share, desktop or Windows, clicking there, then entire screen. First I click share, then entire screen. Do you
Sir,
see now?
sir, make it into presentation mode, sir. Then it's fine.
I'll do that. That is not a problem. Okay. Can you see now? Data presentation in ways to effectively
Yes.
present
Yes.
Yes, sir.
data. Yeah, so far
Yes,
so
sir.
good. Only
It's okay, sir.
when I move there next time, then the problems comes up. Okay. Now, what we do in a chart, why do we do is chart use? The reason is that it is the visual presentation of data, because whatever is visual, that makes permanent impression in our mind, and it gives the information about the business data. Business data means, if you are working in a plant or anywhere, okay, if anybody says so many data in some table or some a notebook or all these things, it doesn't make sense to you. But if it is put in front of you in the form of a chart, you get a visual idea that what was the production last month, and now what is the production in this month. Okay, and good charts convey information quickly. That's what I said. And because if it is haphazardly presented, you will never get the information what happened last to last month, and how the production rate, whether it is increasing or there is a real bad production rate that is happening. So you can make some sense. And also, if you look, if you see some dip somewhere in the curve, just like I look into the electricity consumption, okay, of a plant or in our society, okay, then I can understand, okay, maybe there is some leakage, something that happened, that's why there was a peak. Okay, the electricity consumption was very high. So it is a convenient method to compare. If I want to compare what was the consumption last month to this month, so it gives a relationship, and we can say from the trend that something wrong is happening where we want to correct. Similarly, in a production plant, also if you look into the trend, you can make out what is happening. Okay, I'm moving to the next slide. Pie chart. Can you see? Hello.
Yes, sir.
Yes, sir.
Okay.
No, sir.
Okay. Huh? Some
Yes,
people
sir.
are
Yes,
saying
sir.
yes, some
Yes,
people are
sir.
saying no.
Yes.
Okay, a pie
Yes, sir.
chart is the most popular now. It is one of the chart can be presented in a different form. So one of them is pie chart, and this pie chart is the most graphical method of summarizing quantity. Now, as we know, that pi is nothing but just a slice. Okay, I will get my pie. Sometimes we say, okay, that means I will get my share, whatever that is. That means as if it is it is just like a round separate body and a round separate just like a cake, and then from the cake I'll take my pie. So basically it is visually you have to compare it with the different size of sections, slices, and each slice represent a different category. Just like if I want to compare what are the different marks of your subjects, different country distribution you got. Maybe you got something in strength of materials, you got something in math, maybe engineering drawing. So if I say that okay, there he got this much percent, so out of total marks, maybe somewhere he got 30%, somewhere he got 40%, like that. Then I can easily understand what is your distribution that you got. Okay, and where is the maximum amount that get. Mainly, we'll see that in case of economy or in any kind of distribution, always it is shown. Just like sometimes you'll see that there are different telephone companies, BSNL, Geo, Vodafone. Now, what is their market share? So if anybody wants to compare this thing, always they take the help of the pie chart. So they so that okay, maybe right now Geo is having a bigger market share compared to Airtel. Maybe next one is Vodafone. Maybe least one is BSNL for the time being. Okay, whatever it is. Now, as per the amount of the slice, there will be each slice will get some allocation. So there will be an angle, and which will be proportional. Angle allocated to a slice is proportional to the proportion of time the corresponding category is observed. So as I said, that how much percentage, if you are somewhere you got 40%, somewhere 30%, just like that, the entire circle corresponds to 360 degree, and and so that means 1% correspond to, that is 1% of 360 degree is 3.6 degree. Okay, I move to the next slide. Okay, here is one example. Okay, that day also I told. Today I again so this thing that it is different subjects. Let's say somebody is studying with maybe commerce area, and or somewhere in the commerce area there is how many graduates are taking up those courses. Okay, so the subjects are accounting, finance, general management, market, and others. And number of graduates in each class is shown 73, 52, 36, 64, 28. So if you sum it up, you get 253. So what is the percentage? So if you 73 divided by 253, that makes 28.85, 29%. This one is 21%. This is 14%. 25%, 11%. Now, if I take 360 degree, and then 29% will make 104. So, number one, you look, I'm showing here that my cursor is showing that this subject code 1, actually, this much, that means it is 29%. It is the maximum number of people. From here also you can see 73. But when you compare 73, 64 or 52, maybe it may not look very much appreciable. But when you look into this pie chart, it makes sense that 29%, it's really, it's bigger than 14% or 11%. Okay, so likewise you can have a comparison of all subject codes, how much percentage that is occupied. So this is a pie chart which you use. Sometimes not this is a two-dimensional pie chart. Okay, in some cases also it looks it is shown in the form of a some 3D. Okay, it's nothing. I mean, fantastic. I mean anything. It just visually it looks very much. I mean, appealing. That's why people sometimes want to show it in the form of 3D pie chart. Okay, I move to the next slide. Here is also, let's say, some company, just like if I say ICT company or some ICI or some other company, if they are having different industries, just like if you take about Reliance deals with petrochemical. Also, it has got power. It has got also telecom. Similarly, there are some companies, maybe they are holding Vedanta Group. They are holding different areas. Okay, so if I want to compare how is their business, okay, if I look into their portfolio, so they can easily show in the form of that. Okay, I have this 2.43%, 3.24%. So in the form of a pie chart, one can easily show how is the distribution, which one is having. Just like from this figure, this yellow color is 7.39. Okay, and this color corresponds to here that it is mobile telecommunication. And next to it, almost close to it, but a little bit higher, 7.81%. That is uh, food producers and processors, and which is really on a larger side or higher side compared to this bluish color. Okay, or some sky colored. So from the sky colored, you can say that this is electricity. So electricity is very really low at lower end. Similarly, you can say for this violet 3.28. What is that violet? Travel and leisure. So here that company has got less amount of share. Okay. Now, this is the in brief. This is the pie chart. You can, so if anybody asks you some questions, so what you need to do is basically you have to uh, find what are the different percentage held by each category, and then according to that you have to divide 360-degree. Mainly, it is nothing great into this, and you have already done sometime somewhere in some level. And then we move to histogram. That day also we told that histogram is nothing, just it is uh, continuous or adjoining boxes, and it has got two axes. One is horizontal and another is vertical axis. And in the horizontal axis you put the data, just like if you want to plot the distance from your home to school or office, or somebody else's home to school. Okay, how is the distance? Now the vertical axis is labeled either as frequency or relative frequency, percentage frequency. Now it can give you the shape of the data, center and the spread. Okay, so once you plot it, maybe you will get some type of a trend that you can get. And uh, these are all basic things. Also, other day also said that relative frequency you can calculate from the frequency. Frequency is number of the data, total number of, I mean, that is repeated, I mean, data that is repeated for particular. And relative frequency is that if you divide that frequency divided by the total number of data, so frequency divided by the total number of data will give you the relative frequency. So it's better always to work out some problem, and from there you will get a better idea, or it will be clear concept. Now, whenever we say all these things, most of the time in histogram, we always try to group some data, and we say that these are classes. Okay, and as I said earlier also, the frequency is nothing but number of observation that fall in class. And this class has got always a smallest value and the highest value. So the smallest value is called lower cut point, and the highest one is the upper cut point. And it's not necessarily in each cases that they have to be same or something like that. That means the interval in between the lower and the upper cut point, not necessarily. Okay, and as there are points of lower cut point and upper cut point, okay, always you can have the middle point of them, and that is called the midpoint, the middle of the class, which is estimated by taking average of its lower and upper cut point. Okay, now Also, I mean, it has to be mentioned, and if you also look into this thing, that there is more than one correct way to set up histogram. Maybe you can put your histogram, you choose your lower cut point as something, I can choose something else, and if you take the interval of that each class different than me, you can have only that, it gives some idea. Okay, a value is counted in a class interval if it falls on the left boundary, but not if it falls on the right boundary. So, uh, always we will see in case of a histogram, I'll tell you also later, that we see some kind of a, okay, it is some thickness is shown, and you see the histogram. You see the histogram, and if a value will be counted if it is on the left hand side, but if it is on the right hand side, it is not taken into. Just I'll tell you, okay, show you. And different researchers may set up histograms for the same data in different ways. As I said, that it is a matter of choice how you take the lower cut point or the upper cut point. Now, there are some terms, okay, just like outlier. Now, you will see this thing even when you collect some data or and analyze it, whether for this one or during this or some further analysis, that some of the data, they are not matching, they are not fitting with the rest of the data, and they are called outliers. Okay, how the outliers come? Maybe it's some data has come, maybe there is some um, whatever the your data that was data acquisition, at that time there was some disruption in the data acquisition system, and you got some data, just like or somebody, if it is a manual recording, maybe you have given it to somebody to write it, and maybe he's writing instead of 500 he is writing 50. Now if you want to plot with 50, then we'll go to totally in a different manner. So you have to drop that value of the 50. So these are all outliers. So when you use some outlier, okay, you are plotting some data, okay, to make sure there is no ingress of any outlier. Okay, so you have to be very clear. It will say that something unusual. We have noticed is also even with the data that we receive from the level to automation. Okay, sometimes maybe there is COBOL in the system. All on a sudden, we see the some data. What we get the data here is in the form of PDI or PROC files, and there we all on a sudden. So we immediately detect that there is something wrong, some outlier have come up, maybe there are some system disturbance. So let's remove some data, and we filter out. Okay, after screening of them, we take the only data that, okay. So it happens everywhere. Okay, not only that, there are some skewness. Okay, skewness happen, and skewness is nothing but it is the asymmetry of histogram. So if you plot just like here, you see on this diagram that it is left skewed. It is called left skewed, and it is right skewed. Skewed means that is, okay. On the left hand side, skewed means that it is tail is on the lying on this side. So if anybody says left skewed, you always remember skewed. That means its tail is on the other side. That means this side has got more data on the right hand side. So left side, it is not totally I mean symmetrical. So the data on the left hand side and the right hand side, they are not equal. On the left hand side, the amount of the data is more than the right hand side. Similarly here, right skewed means, okay, the tail, it is just like as if it is more prolonged, and on the right hand side, this area, it looks much larger, and the number of data are lying more on the right hand side compared to the left hand side. So that's why these are called right skewed. So that's what it is written here. A histogram with the normal distribution is symmetrical. So it is perfect normal distribution. That means it will be symmetrical. Okay. So in the same amount data. But if it is left skewed, means left side number of or the amount of the data is more. Okay. The direction of skewness is to the tail. So left skewed means that means on the tail of this side, the left side has got more. Okay. A normal distribution will have a skewness of 0. So we move to the next. So these are just class width, as I said, that it is the largest value and smallest value divided by number of classes. Okay. Now class width not necessarily it would have they have to be same. Okay. So class width basically this is the formula that is used. So here we take up one example. Okay. You see here it is already plotted. I hope everybody can see this. Okay, what is that? Basically, it is high data of 100 players, basically, and they are expressed in inches. So you can see that you okay. Somebody is 5 feet. Certainly, some people are 67.5, little bit on the higher side, 72, 73. So somebody close to 6 feet or even more than that. Now, uh, when we need to plot this thing, see the way as it happens. Now here, the smallest data is 60. Okay, and if you analyze little bit here, you will see that there is one some data has got zero point 0.5. So it is the fraction 63.5, 64.5. So we have to accommodate these values. That means whatever we start with, that should be some fractional value. Okay, then it is better. Instead of just like discrete value, all these things, it may not fit or it will not suit us in a better way. So uh, if it is zero point 0.5 is the fraction used in some of the data, so we can either say use 0.5, 0.05, 0.005. But if I use 0.005, then it may be, it would be more precise, but I have to make, calculation and everything. I have to take care of that. Okay, I have to put my head more deeper into that everywhere. I have to have a housekeeping thing. Okay, so uh, if I just take out of them 0.05 and subtract it from 60, I can use 59.95. But it's not necessarily I have to do like that. You could have taken zero point 0.5 also. So you could have started with 59.5. Okay, that would include. And if you do that, and maybe your largest value is then 74, and you add 0.05. So uh, then your starting point is 59.95, and end point is 74.05. And I want to choose 8 bars. I could have chosen it as 10 number of bars. So it totally depends on me. In that case, it would have been divided by 10. So I want to get what is the width of each class. Okay. So if I say 8 bars, I want to see what is the thickness of width. Okay, here. So 74.05 minus 59.95 divided by 8, it gets 1.76. Now, in a scale, it's very difficult to plot 1.76, or you have to search for this thing. Okay. Uh, so it is totally dependent on your choice. Instead of 8, you could have taken it as 5 or 4 or 10. Accordingly, your width, so this width, okay, would have been different. Now, width of each bar of class interval, here it is chosen as 2 instead of going to, because it is for the only purpose of your convenience. You cannot search 1.76 from the scale. Okay, if it is given to you in a plot or anywhere. So the last point is If I take 59.95 and there are 8 bars, then 2, it would become 75.95, which is more than 74. Okay, but it doesn't matter because what I want, basically in histogram, we want to plot how it looks like. So if I take 59 to 61.95, you see how many data I can include or I can cover in this range: 60, 60.5, 61, 61, 61.5, up to this. So, 5 number of data I can include here. Again, in between 61.95. So I can take some average here. Okay, I say it is okay. And how is the relative frequency that I can calculate. So that's the way. Just like here, I have seen that. Okay, this is the area in between 65.95 and 67.95. There is a density of numbers, density of heights and more. You can also look here in between 65.95, okay, and 67.95. You see, large chunk of data. So it is supposed to be the highest relative frequency that one can get. So eventually it would give you almost close to a normal distribution, or here is the peak, and this curve goes like this thing. If you try to start from here and try to connect the peak here up to and go all the way up to down here, you will always get, okay, like this. Okay, so that's the way you have to plot. If it is asked to you, you have to show some kind of thing. So it is your judgment. Okay, but whatever judgment, whatever path you follow, you have to defend it. That's the main point. Now, you may recall that at the very beginning, I showed it on lecture 1, that example of hot stream mill. There also we take this thing and uh, we plot the value of the speed and number of observations. Okay, and there also we can see that in between 8.5 to 9, okay, the large cluster of data is available here, whereas lower end 6.5 and around 10, the less number of data. Similarly here, thickness is plotted, so I can say, although okay, a range of thickness have been rolled, but in between 3 to the data that I had taken, the samples that I was analyzing, they were actually having the thickness of, okay, in between 3.2, 3.4, and it was for a particular grade, that was a T01063. So that's why for that particular shift or that particular day, uh, these so many numbers of coils were rolled. Here you can see 220 coils. They are having this thickness in between 3.2 to 3.4. Maybe for other grade there will be different distribution, and maybe there. Okay, so if you want to focus your attention to a particular coil or particular grade of thing, whether in your plant or some other plant, you can analyze like this. Next, I move to this. Okay, this is some kind of announcement. I want to inform you ahead, and this is that your tentative date of first mid sem is going to be October 07. Okay, and um, these are all the way down. Okay, don't think about them too much. And quiz number 1 has already, you have gotten your result. Quiz number 2, quiz number 3, I'll tell you. Okay, once after October 7th, I'll tell you that day also, that October 12 is going to be the quiz date, like that. So we'll proceed like this. Okay. Now I have one point also to tell you, that in your homework, I was just glancing, I was just having a look into that only. You were asked whatever it is, the direction that have been given, you just follow that. Okay, it's just not the tick mark I wanted. Okay, in the homework, in quiz, that's all right. and you whenever you come for homework, whenever you come for quiz or exam that day on October 7th, be prepared, come with preparation. I mean, that means you should have either your laptop or desktop or whatever it is. Don't tell that mobile is not working or like that. You are, I mean, I assume most of the time either you are working from your home or from office, okay, somewhere. So be equipped yourself with that day. Don't tell that I'm going to submit it after 1 hour or so. Okay, and same is the point for also homework that you after 1 or 2 days of that you don't tell me. Okay. That means I if I start grading, then it doesn't become more fair. I mean, it doesn't become equal in that time. Okay, so I want to have the everything in the same level. Okay, all right. Now let's take another example of and in which we'll try to cover the different pie charts or histogram, whatever it is that we discussed. Now, what is the meaning of the term inn? Guest staying at an inn. What is inn?
Type of
Hello?
hotel.
Huh? Yes.
It is used for hotels which have many branches.
Okay. I mean, where did you read the word in general?
Most of the time in hotel
In
names.
yes, sir.
It means hotel, but it's on the way of the road, on the wayside, I mean, roadside. Okay. When there are some travelers, just like, okay, I think the source of the name of the McDonald that have come. McDonald is basically on the side of the highway of, okay. So it was, initially it was for, I mean, the truck drivers that they used to take the rest on the side of the road and then used to, okay. So in actually you'll see most of the time in some English book, that means British book or somewhere, you'll see that they write in. Yeah? Uh, and sometimes you'll see that parabola of good Samaritan or somewhere in this kind of stories you will see that. Okay, in general we don't use the term inn. Yeah. Either we say hotel or something. It's like, just like we don't use the term motel, we always say the hotel. So there is a difference between hotel and motel. Similarly, okay, fine. We moved here that the guests staying at an hotel are asked to rate their quality. Okay, so they are asked to give the rating, and they gave the excellent, um, above average, average, below average, or poor. And there are 20 guests, and they gave the average. I mean, they are rating like this: below average, above average. So you have to get some their I mean, how they look like this. Okay, or how the feedback. This is a feedback form in which they have given, and it looks like that. So if you start counting, then you can get that above average is so many numbers, average is so many numbers, poor is how many, one, two, like that, average. Okay. So uh, now we can have the frequency distribution. Poor, if we start counting, that there are two numbers. So frequency is 2, below average is 3, average is 5, above average is 9, excellent is 1. So you make the sum 20. So what is the relative frequency? 2 by 20, 0.81, 0.5, 0.25, 0.45, like that. And if you add them up, it should give you 1, because this is all fraction, right? This is the fraction that you get. Now, okay. So again, it is the same thing. So relative frequency that you got 0.1, 0.15, 1, it makes 1. And how did you get it? That it is written. And percent frequency is like that. If I multiply by 100, it would give you 10%. Okay, so it is 100. Certainly, it should. Now, if I want to have a pie chart, I can easily say this thing. Okay, that 10%, 15%, 25%, 45%. Above average is so much. Excellent is 5%. So with the same categorical data, okay, it was categorical. So what kind of this feedback are? I mean, if I want to subdivide uh, categorical data, is it
Ordinal data.
huh?
Ordinal.
Ordinal? So it's not nominal, it's ordinal data, right? And there you can put it in the form of the just a pie chart, right? So again, the same data, same feedback, I can put it in the form of the bar graph. Just I put poor, below, okay, like this thing. Okay, here it is poor, below average, average, above average, excellent. The bars are separated to emphasize the fact that each class is a separate category. That means poor is not the same as below average. All these are category. So that's why they are categorical data. Okay. So here on this side, rating is plotted. This side is frequency. So the same data, I can put it in the form of the bar graph as well as the pie chart. So similar type of question may be asked. Okay. Now, bar charts, okay, is a type of graph used to display and compare the number, frequency, or other measures for different discrete categories of data. One of the most commonly used type of graph of these charts, and it is flexible and simple to create. Bar chart. Several variations of the standard bar chart, including horizontal bar charts group. Okay, here I showed you that this is looking vertical. Not necessarily it has to be vertical. I can put it in the form of also horizontal. It's only the matter of the space. If I do not have space and I see on the, if I go towards the horizontal side, I have the space, but I do not have the on the vertical side, I can put it them in the form of the just like a horizontal plot. Okay, it's just my choice. It's not that there is any sacrosanct or any kind of any fixed rule that I have to follow that. So bar charts I can give you in the form of the vertical bar graph, or I can put it in the form of the horizontal bar. Displays data better than horizontal bar graphs. So that's why people look it. Okay, why we plot it vertical? If anything that in front of us, in front of our eyes, if we see that okay, it looks vertical. Okay, so it looks okay. This one is the. I mean, here just by looking at here, I can say that okay, this above that value. Okay, I don't even look at this, but this is really higher from this. So I got this rating, the maximum rating, even compared to excellent or average. Okay, it's almost twice as good as this one. Okay. So I don't look into the number or this value, digital value of the. Okay, so that makes some kind of impression when I put it in the form of the vertical compared to the horizontal. See here in the horizontal, okay, these are here, but I'm not really feeling that much comfortable. Okay, to compare with, whereas I am comfortable with this kind of data. That's a, I mean, matter of impression. It's a personal impression that makes. Maybe for some people that horizontal would be more impressionable. Okay, it makes more impression to him and not to me, like that. Okay, and horizontal bar, when you use it, the category names are too long. Okay, I cannot put it here like that. Too long to fit at the foot of the column. Okay, uh, like that. Now we have done so much thing, and earlier we talked about pie chart, then we moved to histogram, and then bar chart. Now tell me one thing, that we plotted we plotted bar chart as well as histogram. Okay, now what's the difference between them? What's the difference between histogram and bar chart?
Sir, the category,
Which
category
one
or
is
class.
which one
In
is
bar
category?
chart, Yeah, in bar chart, there is clear-cut category which is separated, but in histogram, the classes are somehow interrelated. They are in continuous manner.
Right. Right. In a histogram, you always deal with the data of the same category. Okay. Uh, Basically, that's why you will see that one is attached to the other. Okay. In histogram, whereas in the bar chart, there is always some separation because they belong to the different category. Here also it is said that different discrete categories of data. Okay, so whoever plots, he will not put this one. I mean, on the it will not be continuous. Whereas there it is said that it is contiguous. That means it is adjacent. So it will always be. That means that it belongs to the same category. It's just like a subclass or whatever you say. So that's the thing. You have to be very careful. Which way you want to plot, which graph you want to adopt. Okay, and also just like if I want to have the comparison of the wildlife, just like in some national park, let's say Kaziranga National Park or some other national park. Okay, they say the number of the rhinos are going down each and every year, and if you want to plot them, okay, we can have the plot. If we say that, okay, the last year was like this, or 2017, 2018, 2019, this, and maybe it is again increasing. Okay. Whereas the number of the tigers, they are always steady. So I can put the number, they are plot here in the form of the with a different color. I can show in 2017 their number was this. In 2018, number of the tiger was this. Okay, so side by side, I can compare these two different categories. Just like in this plot, they have shown the comparison of dolphins and whales and how their numbers are increasing or decreasing. Here you see dolphins 2017, again it has dropped 2018, 19, and it is slowly going towards zero. Whereas whales, okay, they had gone down, but again increased again. So it is just like a zigzag, okay, going up and down, but it has remained almost steady. It is not so much alarming. It's not so much alarming like dolphins. So one has to be, so whoever is in charge of that particular wildlife area, he or she needs to be very careful to take care of dolphins. So that's why it is says that bar graphs are best used to compare things between different groups or to track changes over time. So I can say that in a period in between 2017, so they have predicted also this thing 2021, 2022. So how it is going to change. However, when trying to measure change over time, bar graphs are best when the changes are larger. That means, yeah, year one can easily say that, okay, it is alarming, 140 compare, and this one is 80, and it is going down and very fast, 30, then it is less than 10 or so, like that. So you can compare and say that the changes is very, I mean, sudden, and it is very fast. So one has to be really careful. Okay. So move to the next. Again, another example of bar chart. We deal with that accounting survey area, number of graduates, and we can put also in the form of the bar chart. Earlier we showed it in the form of the uh, pie, okay, pie chart, and there we showed, there we showed how it was, and here now it is being shown in the form of bar charts, okay, and it shows that this count of area, okay, and it shows that the one data was 73, another was 52, 36, 64, 28, and that's the way, and one can easily understand that, oh, this subject, okay, or the, if I go by the code, I can tell for this code this was the okay, highest number of students. Here this is a little bit lower than this, and least number of students are present for this. Okay, now Apart from all these plots or all these things, there is one is called line graphs. Line graphs is just like it shows the data with the time, okay, how it is. Now, it is how one variable is behaving over a period of time. How, if you want to show that in x-axis, you put the continuous variable or the data that you want to show, ER or distance. In the y-axis, the measurement, just like, okay, uh, instead of just like a bar chart or like that, if you want to take just like one point, if I say the number of rhinos was 220 this year and number of this in the next year was like, so in 1 year the change is this much, so I can say, okay, from 220 to let's say 180, the number of the, just I took some point. That's the way we generally plot in our data, we in the experimental things in the lab. Whether we started it at class 11, 12, or first year, second year, we take some data point and okay, say with the time this value is this, okay. Um, uh, so number of physics, okay, so experiments we have done like that, okay, as well as the time series data. Line graphs can also have appropriate for displaying data that are measured over other continuous variables such as distance, that you can do. And also just like here is one example of pollution level. If pollution level is varying with increasing distance from a source, mainly in other countries they do it, the variation of the level of the chemical with the depth of soil. If there is some chemical, just like if you are from Bihar, you may be doing this thing, that the arsenic level, okay, arsenic level that has been measured with the variation of the soil. And I don't know whether you know what this thing or not. It is the many areas of Bihar have been, people have been affected with arsenic, even also in West Bengal and all those things. And one scientist was telling that the beauty of the thing is that if you go deep down, if you bore something, or if you take the boring water, that may be a source of arsenic. Whereas if you take water from just like close to the surface of the nature, there is no such a threat. So whatever the water that is taken by cows or animals near the river, they are never exposed to arsenic. That's the nature of the mother beauty. But a human being, they want to go deep inside, bore inside, and where is the level of the arsenic is really high. So if you want to have the analysis of that chemical arsenic, then you can have the variation of the level of chemical with the depth of the soil. So here is some example that have been shown that if I want to see that with the passage of the time, okay, what are the production of the light trucks, okay, larger trucks, motorcycle, buses, and other unknowns passenger. Here is the distribution that have been shown. Okay, so this is one way of showing the line graphs. Here you don't show this. I mean, in form of the bar chart or all these things, okay, just like you can say from here that okay, this was the 1994, 1996, 1998, how the production has increased for some okay, some production just like light trucks, whereas for the passenger car it is the larger, a large truck, no, large truck is this one, passenger is here, colors they almost look like that. Okay. Whereas motorcycle, they almost remained, and it has picked up after 2004, 2006. Okay. Now, which choice, you have so many, I mean, charts, which one you should pick up and should use for this thing? So you have to be very careful that pie chart is small and intermediate number of categories cannot show order of categories. Okay, it does not give the impression just like bar chart. In bar chart, you can easily understand. Okay, fine, which one is, and it emphasizes only the relative values. You can say 29%, 24%, 25%. So it is the relative values that it is very clear. Whereas bar chart, it is small, intermediate, similar thing, and present categories in a particular order, if any. So I can say, if I want to put it here, just I am showing here. Okay, I can just, if I want to show bar chart, I can put first passenger cars and put them in the visibly, I mean, highest number of bar that I can show. Then I can put, okay, large trucks like that. So that order is, it is my choice. I can put them. Okay. But if I put them in 1, 2, 3, 4, okay, that percentage wise, it doesn't show like that in pie chart. So that's what it has been described here. Okay. That's what it is said, that it cannot show order of categories. Whereas bar chart, it can show the categories in a particular order. And you can see the relative values. And okay, I just want to say this thing. With this, I will come to end. That day, I say also about scatter plot, and I said that this one is basically when some seed is rolled out, and there is always some profile that it gets bent or something like that. It's not necessarily it will come with a flat plate or flat coil or something like that. Similarly, in your case also, if you have some kind of production plant also, you can see, and here it is plotted that actual profile, and that is one is there is one equation that has been. Similarly, you see also some other data also, you can have this scatter plot where you have the actual value, experiment value. One is that you get it, and another one is predicted value. Okay, it's not necessarily profile that you have to measure. Okay. In your plant also, if you can have some theoretical formulation, you can have the predicted value as well as the observed value, and you can plot. So just to have the idea about profile, I just going to show this thing. As you know that in case of a rolling, okay, this is the slab or whatever seat that goes in, and thickness get shortened. Okay, and these are the two rolls, right? These are called work roll. Okay, and whenever it comes out, it's not necessarily it has to be flat. You see, these are edgy wave. That means on the side of the wave edge, you see here it has bent like this thing. That is one kind of a waviness that happens. And if it is center buckle, that means in the center there will be some kind of a buckle. Okay, that kind of and it happens for the thinner gauge. That means if it is a thinner kind of plate or I mean coil, it doesn't happen for a thicker coil. It will not happen for 10 mm. There will be, but certainly, but not that much. Whereas it is very much predominant. Okay, and as you know that if your slab that goes into here, there are always two work rolls, and there are these yellow color backup rolls, and there are some okay bearings that are used, and with the time, okay, uh, during one what they call it what is called, it is schedule. Anyone working here with a rolling mill? Hello, hello, can you hear me?
Yes, sir.
Yes, sir.
Any of you work in rolling mill? No.
No.
Acha. If it is no, then let me tell you, there are in the rolling mill, what happens, these are work roll, and what they do is basically this work roll are used for rolling a particular schedule. They say that, okay, in this schedule, we'll be rolling about 40 or maybe, okay, 70 slabs like that. So that depends on the your customer demand. So they give this, and they schedule it. That means they already plan it. That is called scheduling. And each schedule that takes about running for 4 to 5 hours. And during that schedule, these 40 to 60 slabs are rolled one after another. Okay, while running at that, due to heat and all these things, okay, these rolls that get some wear and tear that happens due to thermal effect and all these things. So these rolls, their shape becomes something like that. Okay, one is that is called a negative crown. This is called a positive crown. So at the end of the scheduling, there is some changeover time is taken, so during which this this work roll are taken out, and they are sent to a machining shop in the CNC machining. And whatever that wear and tear that happens, that is in the order of the micron. Okay, 75, 70 or 60 micron, where their limit is 75. So they call it the crown that happens. Accordingly, you see this slab has gone in between. If your shape becomes something like that, so subsequently the shape of the coil that comes out, that will be also okay corresponding to this. So it will not be just like a flat. In one side it would be a little bit in the middle maybe it is just like bent like this thing. Okay, so that's why what they do at the end of the schedule, after every 4 hours, they take out this and put some new work role. That is called changeover time, and this is called the scheduling. Okay, so every schedule they have to change this work role. This will go, and after a while they cannot machine further. So then they have to scrap that work role. Okay, that's another science or technology. But just to tell you this one, I explained all these things that this profile. Maybe some of you, if you work in some paper mill or some other rolling mill, you will have this in the future. In short, I tried to explain this pie chart and then histogram, bar chart, time series, scatter diagram, frequency table we already did earlier, frequency distribution, stem and leaf plots. Okay, so with this, I come to end today's lecture. Okay, so we'll meet next week. Okay, if you have any point, you can mention, or if you have some question or something, you may send me email. I'll certainly get back to you. But be precise what you want, because I have seen someone was asking, or somebody gave comment. I just want him. I asked also him. Uh, he doesn't know whether he was appearing for homework or quiz. Okay, so be careful what you are doing. Any question? Okay, if there is no further question, so the class is dissolved for today. Okay. Okay, we'll meet next time.
Thank you, sir.
Okay, welcome.